Hi everyone. I want to do an example using linear programming. This is example 1143 from your textbook. So I'm not going to read all this to you. You can pause this and read it yourself. We're going to do a two-product constraint. And we're going to use linear program to decide which product will be the best one to produce and how much of each one. There's a couple of ways to do this. We'll do it manually first. Well, first we want to look at a couple of things. And we can ignore corner point analysis. We're not going to do that. So we're given all this data for a company that makes windbreakers. And we're asked to determine the contribution margin per hour, the maximum production per month, and the maximum contribution per month for each product if the sewing machines were the only constraining resource. We're asked to give this information from a strictly financial perspective, which product we recommend. So let's start with that. Let's just start with figuring out if sewing is the only constraint. The first thing we want to do is calculate our contribution margin. So we are going to take sales minus variable cost. This should be really normal to you at this point, equals contribution margin. And we want to do this for calm, and we also want to do it for windy. So the sales price of calm is 30, and the sales price of windy is 32. The variable cost is 24 for both of them. And we want to figure out the contribution margin. So the contribution margin is 6 for calm and 8 for windy. So we can just infer right from here that we should be making windy because we have a higher contribution margin. But we need to show that. So they've given a lot of information, and you really have to pick through this. Let's start with the sewing time per jacket. Because we've said that in here it says that the sewing machines are our only constraining resource. So we really need to know how much time we have and how many jackets we can produce with that. So the sewing time per jacket, and if we pick through here, we can figure out, let's move this over just a bit, that the sewing time is 4 minutes for a calm jacket and 3 minutes for a windy jacket. And I want to put minutes here because it becomes important. So how many jackets can we make per hour? Because they've given us, what they've done is they've given us this machine that can do 1,200 hours per month. So we need to know how many jackets we can do in an hour. So we're going to take jackets per hour. We're going to take 60 minutes divided by the sewing time per jacket, because there's 60 minutes in an hour. Sorry, my phone's ringing. There's 60 minutes in an hour. So we're going to take 60 divided by how many minutes it takes. So we can do 15 jackets per hour. And we're going to do, for the calm, and we're going to do the same thing for windy. So we can do 20 jackets per hour there. So what's our contribution margin per hour? Let me just type this here so you know this. So this is 60 minutes divided by sewing minutes per jacket. I have to pause for a second. Okay, contribution margin per hour. This is the jackets per hour times the contribution margin. So our jackets per hour are 15 times our contribution margin for calm gives us a contribution margin per hour of $90. And let's just make sure that we see that's $90. And we'll do the same thing here. Jackets per hour times our contribution margin is $160 contribution margin per hour. It's becoming clearer and clearer what we need to do, right? So let me just put that here. This is jackets per hour times the contribution margin. How many hours do we have available? Well, our maximum number of hours, they told us on the machine, is 1,200 hours. So we have 1,200. And we're going to figure out maximum for both of these. Okay. So the hours available, the jackets per hour of 15, and this one is 20. That gives us a maximum production of 1,200 times 15 and 1,200 times 20 for windy. The contribution margin per jacket $6 for calm and $8 for windy gives us a maximum CM of 18,000 times 6 and 24,000 times 8. They don't like it when we mix and match. We're ignoring those errors. So we've answered the question for one of them. From a strictly financial perspective, which product would you recommend to produce? They asked us for the maximum contribution per month for each product if the sewing machines are the only constraining resource. Well, we would probably do windy because we can make a contribution margin of 192,000 versus 108,000. And I just realized constraint, not constraint. Sorry. So now we want to determine the same thing, assuming that inspection and packing activity are the only constrained resource. So we'll recreate this. using, what is it, inspection and packing the only constraint. Okay. So again, we're going to do calm and windy. First, we'll look at inspection and packing. Let's just call it inspection so we don't have to type all that. Inspection for calm, if we look at our numbers, it says, it talks about the inspection part. Calm jacket takes 6 minutes, and the windy jacket takes 15. So 6 minutes and 15 minutes. And be sure to put minutes so we don't lose track of what we're looking at. So how many jackets per hour can we do here? We're going to do the same thing. We're going to take 60 minutes divided by the number of minutes it takes. So we can do 10 of the calm and we can do 4 of the windy. So this is 60 minutes divided by inspection per jacket. So what's our contribution margin per hour? We're going to take the jackets per hour times the contribution margin. So our jackets per hour times our contribution margin for calm, our jackets per hour times our contribution margin for windy. So 60 for calm and 32 for windy. And again, those are dollars. And we'll just copy this because we're doing the same thing. Jackets per hour times the contribution margin. And then we're going to recreate this. Hours available. In this instance, if we look over here, there's actually 5,600 hours available. We're going to do that for both. We're going to make sure we have our commas in there. How many jackets per hour? Well, we've already calculated that. 10 and 4. So our maximum production would be 5,600 times 10 and 5,600 times 4. Contribution margin per jacket, 6 for calm and 8 for windy. And we're going to get a maximum contribution here of 56,000 times 6, or 336,000. And let's just add dollars to this. And we're going to do the same thing here. So if inspection and packing is the only constraint, then which one are we going to do? We're going to produce calm, because look at the difference. What if, and this problem actually asks you to do, to graph this and do some corner point analysis, but we're going to skip number 3. We're actually going to do number 4, using 2 constraining resources. But we're going to let Excel do that for us. So number 4 is linear programming with 2 constraints. Because the issue is there really isn't only 1 constraint, there's 2. So we need to take them both into account. First, we need to set ourselves up with this. So we're going to start with our product. And we have 2 products. And bear with me as I walk through this. We have calm and we have windy. And then we're going to make a sales in units column. We're going to make a contribution margin per unit column, because this is all information we need to have to be able to calculate these numbers. And then we want to look at per unit consumption of the resource. I'll make this just a tad bigger. So we want to look at per unit consumption of the resource for sewing and inspection. Again, all information we need to have. Then we're going to create some formulas so Excel can work with it, like the total contribution margin. And then we want to look at capacity usage. Oh, what am I trying to do? Oh, I want to merge and center this and bold it. Down here, it's sewing time. And inspection time. All right. So I think we've got it kind of set up the way we want to look at it. Let me just add some lines so it's easier to read. Sales in units, we don't know. This is what we're going to ask Excel to do for us. Let me just center all these. Ugh, don't do that. Just center all these so that they're easier to understand. So what's our contribution margin per unit for calm and windy? 6 and 8. What's the sewing time for per jacket? So it's per unit of consumption. So my sewing time per jacket is 4 and 3. For inspection, it's 6 and 15. And these were given in the problem. My total contribution margin would be my sales in units times my contribution margin per unit. So I'm going to put that formula in here. Sales times my contribution margin per unit. My sewing time would actually be kind of the same thing, right? It would be my sales in units times my per unit consumption for sewing. So my sales in units times how many minutes it takes, and inspection times the same thing. My sales in units times the amount of inspection time. Oops, what did I do? times the amount of inspection time it takes. And I need to do the same thing for windy. But I could just, well, I'm not going to do that. I'm just going to run through these again. So my total CM is sales times my contribution margin per unit, my sales in units. The capacity usage is my sales in units for sewing times my sewing time per unit. Sales in units times my inspection time per unit for windy. And one last thing I want to add down here, I want to add some total boxes. I want to sum my total contribution margin. I want to sum my total, sum my total sewing time, and I want to sum my total inspection time. Because those are constraints. The sewing time and inspection time are constraints. Okay. Now I want to do some data analysis. I want to hit data. And I'm going to hit solver. And my objective is to tell me how many sales in units for each one. So my objective, my objective is the total contribution margin, sorry. I want it to tell me how many units for each one. Okay, for some reason I managed to lock up everything, sorry. I wanted to show you, I wanted to flip over and show you, and I may have gotten a flash of it, but I can't do it. So in the appendix in the textbook, there's an example of this as well. So let's continue. We want to set our objective to our total contribution margin of a max amount. In other words, we want to maximize our contribution margin by changing variable cells, the two sales and unit cells, subject to some constraints. The constraints are it disappeared behind everything. Sorry, I have too many things open. So the constraints are total sewing time must be less than or equal to, and we need to look at our things. So our sewing time, each machine can run up to blah, 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 blah. That gives us 1,200 available hours per month. But if you remember right, these are in minutes. So we need to take 1,200. Oops, let me not do that. Sewing time of 1,200, and I'm going to have to do this off screen. Or sewing time of 1,200 hours. Times 60 minutes. That gives us a constraint of a maximum of 72,000 minutes. We're going to add another constraint for inspection time. Inspection time is 5,600 hours. So that total inspection time must be less than 5,600 hours, but we're going to do it in terms of minutes. So 5,600 times 60 minutes gives us 300 and, oops, not there, J39, 336,000 minutes. So now we've got some constraints. We'll use simplex here, and then we'll simply tell it to solve. you end up with something solved here. And I'm not sure this is right because I lost everything, but I will go back and look at it. And we'll look at our answer. So we want a report of an answer. And it actually dumps it on a different tab. So I'll double check these numbers, and if they're not correct, I'll post an addendum to this, because I don't know what happened when I froze Excel and had everything in the background. But I will double check it. Our answer report tells us, and it's not so much about the answer, it's about what we're doing. Our final value, our total CM is 184,000. We have, we can look at the constraints, and we can look at sewing time and inspection time. And if they're binding. Binding means, did we use them all? And we did. If we didn't use them all, we would have some slack numbers here as well. So let me go back and double check these numbers. Let me stop this recording and go back and double check my numbers and make sure they're correct. And then if need be, I'll add to this recording. Okay, I just shut everything down behind the scenes and redid these numbers, and yes, these are correct. So this is an example of linear programming, or determining a product mix, the optimum product mix, to maximize our total contribution margin. We could just, the problem with these are we're assuming one constraint. And yes, you can do a different analysis called a corner point analysis with graphing and such, but this is much easier to do, despite how difficult I made it seem through this process. So I apologize for that. I will post both the blank sheet. Well, I guess I'll just post a blank sheet so that you can work along with me through these. If you want to come to class tomorrow night, you're fine. You're welcome to come to class. I will be there, unless for some reason this cold seems to return. It seemed to be a short one, so here's hoping. I will be there, and I will be logged into the virtual meeting from the classroom with the cameras. So you can join a number of ways. You can come in person, you can log in, or you can just ignore it altogether if you're comfortable with this. We're going to work on this one more time. We're going to do this in groups. Be sure to take a look at the updated course schedule that I will post in the Chapter 11 folder. So we'll work on this one more time after Thanksgiving. Thank you. I'll either see you tomorrow or I'll see you after Thanksgiving. Have a great holiday.